Hello, any idea of these answers? Why mountain top is so cool? Something like ice-capped mountains, we often say. But yes, mountain valleys, these are somewhat cool resorts for us. And some other questions like oxygen cylinders are carried by the climbers. And yes, whenever you go through any Ghati road or just travel through a hilly area, you feel some type of sensation in your stomach. Well, and yes, why do astronauts wear spacesuits? Very interesting answers are there ahead, so keep watching. So here is the solution. Atmospheric particles are nothing but the composition of different gases like oxygen, nitrogen, helium, hydrogen, and everything as such. Even there is particles also. So in our upper atmosphere, these are quite richly available like oxygen. So we don't feel much suffocation, and we can peacefully coexist with the atmospheric particles here as the pressure is also balanced. But as you climb up high onto the mountains, then the oxygen content is reduced, and also you will feel like nausea type of a vomiting sensation. So your eyes get tremendous pressure because that is the high pressure of your body, but comparatively surrounded by low pressure. Okay, so yes, your ears get a tremendous pressure, your eyes get bulged, and your nose may also start bleeding if it is of intense pressure right on the top of the mountain. So you need to keep a balance, and you need to wear clothing as such, and also you need to carry oxygen cylinder because oxygen is very less available at the top of the mountain because there is not much availability of atmospheric particles. And now the point of discussion is about why do we usually feel slightly cool early in the morning but very hot due to the sun's rays or whatever it may be. Like in the sense, suppose early in the morning you feel somewhat cool climate, but by 9 or 10 o'clock you feel the sun is searingly hot, and by 12 it's okay, and of course at 2 o'clock in the afternoon you feel very hot. So why these fluctuations? Any obvious answer would be like it is due to the sun's impact, but this is wrong. I completely disagree with this. This is not due to sun, but you might be wondered by the answer. It is due to the earth impact. There is a concept called heat budget, and just like budget, this is heat budget. Here you will understand the role of earth, which is itself leading so much damage to us because the temperatures are not determined by the sun, but in fact it is due to the earth. You see, there are 2 points to be discussed over here. In stratosphere, or this is the stratosphere, this is the troposphere. As height increases, here the temperature decreases, but whereas here as height increases the temperature increases. This is because in troposphere convection takes place, but in stratosphere conduction takes place. You see, there are so many atmospheric particles over here, so this is quite unstable. And also your aeroplanes, whatever it may be, like jet streams and all, they usually take their ride in the lower layers of the stratosphere because it is because in stratosphere we have conduction, so there won't be much turbulence effect for the airplanes to make their way ahead, whereas in troposphere the air is quite unstable, so warm air tends to rise and cold air tends to sink down, and there will be particulate movement of air molecules, aerosols and all, so that acts like obstacle for the flight to move ahead. Whereas here it is as height increases, we know that the temperature increases, so this is hot, warm, cool, and air is bad conductor of heat. So here conduction is taking place, so yes, the transfer of heat is quite less, so hot air stays above itself and cool air is below, and here there is a tropopause, so the air molecules are obstructed and they can't enter into the stratosphere. And also there is less gravity, so the air particles are not held here, so they obviously get pulled down, and much more air particles are concentrated near the earth's surface itself, so large number of air particles concentration. And similarly the atmospheric pressure is high for the troposphere layer compared to the stratosphere. So now I think you got the answer for why as height increases temperature increases in stratosphere, because of the conduction, and there is no such thing called warmthness to be felt because it is quite far from the earth's gravity pull, so less number of air particles are held, so obviously it is like conduction taking place over there. So yes, stratosphere directly proportional to height and temperature, whereas in troposphere it is normal lapse rate. That means as height increasing or altitude increasing, the temperature is gradually decreasing at the rate of 6.5 degrees Celsius per kilometer. This is due to the fact of convection, so it is quite unstable. Warm air tends to float or expand and rises up, whereas cold air sinks down, and yes, the gravity pull is what led it to get attracted to the earth's surface, so the sun's heat is felt intensely closer to the earth's surface, and convection is taking place, so particulate movement of particles is taking place. And yes, these gases are quite important in trapping the heat, because the atmospheric particles are much concentrated just above the Earth's surface, that is in the troposphere, and it comprises of a lot of air particles, molecules like CO2, oxygen, water vapor, etc. and all. So they are more potent in trapping the heat also, so that's why we feel such warmth. And gradually, while moving above, the gravity decreases, so the number of air particles concentrated also decreases, so the heat we feel, or the warmthness that is held by these atmospheric particles, also decreases. So at last also there is a tropopause, and hence they enter into the stratosphere, where obviously again height is directly proportional to temperature due to the process of conduction. So that's the reason here. And yes, the conclusions we can draw over here is that major source of atmospheric temperature is Earth, but not the sun. This is due to the concept of heat budget. This is quite interesting fact, because the sun rays, insolation is there, but our Earth is what that regulates the warmthness felt by us in the atmosphere. The heat budget concept is quite easy. For suppose you see, this is the solar insolation, which is 100%, of which only 65% is entering into the atmosphere come Earth's surface. On the way itself, 35% is reflected back. This is known as albedo. White colored buildings, white roads and all, there the sun rays are on the midway itself, they got reflected back. So leftover is only 65%, of which 51% enters the Earth's surface. So any body that receives the heat, it tends to emit out. So the 51% is again emitted out by the Earth's surface, whereas the 14% is absorbed by the atmosphere. So of the 51% that is emitted back by the Earth's surface, this is known as long wave terrestrial radiation. 34% is received by the atmosphere, so this is by the atmosphere, whereas remaining 17% is left back to the space. That means it completely goes out into the space. So here what that is the atmospheric warmth that is absorbed is around 48%. So of the 65%, 51% is lost. So 14% is only from the sun, whereas 34% is from the earth. Altogether it is 48%, but of course you can clearly see that the warmthness the atmosphere got is due to the earth's long wave terrestrial radiation, which is huge, 34%. So that is a concept of heat budget. And yes, again another conclusion is maximum temperature is not at 12 o'clock but at 2 to 4 p.m. This is due to the fact that whenever there is high temperature, equator, of course, direct sun rays are there overhead. We can know that easily, isn't it? So yes, direct sun rays are there. So whenever high temperature is there, the atmospheric air particles expand. Heat means expansion. So air particles expand and they rise up and they form clouds. So as clouds are formed, they obstruct the incoming solar radiation, and also that produces like shadow kind of regions. So yes, it's not in the equator, but on 20 degrees north latitude that the highest maximum temperature can be felt. 20 degrees north it is said, but not the south, because in south it is of water. And there is another fact that land becomes much quickly warmer than the water. There are obvious reasons. We will see it in the next video. I have written the question also. I will discuss it in the next video. Yes, and 12 o'clock to 4 in the sense, yes, overhead, but at the overhead the sun rays will be falling, but it will be somewhat formation of clouds take place, so we feel shadow like, okay. And of course here also not at exactly at the equator, here also the same reason, clouds will be formed, okay. And time taken by the earth to absorb sun rays and radiate back, maximum sun rays are obtained at 12 o'clock itself, but I have already told you that the warmthness of the atmospheric temperature is due to the earth. So earth receiving the radiation is okay, but earth re-radiates or emits out the radiation, long wave terrestrial radiation, which is very high, and that is what is leading to the intense heat of the atmosphere. Not the sun, but the earth's long wave terrestrial radiation is what is leading to the intense atmospheric temperature. So here for the earth to receive it exactly at 12 o'clock it receives, but for it to burn out, to eject out the long terrestrial radiation, it takes some time now, so something like 1 to 2 hours. So we can say that maximum heat re-radiation from the earth in the form of long terrestrial radiation takes place at around 2 to 4 p.m. So then we can feel much more intense heat of the atmosphere. Okay.